Two-way tables are a really useful tool for allowing us to look at two categorical variables at once. So you can see an example here. We've got on one side, we've got cell phone type, so iPhone, Android, or other. On the other side, we have age group. Notice that age here is a categorical variable. A lot of times with age, we would think of it as quantitative, but here we've grouped people into three categories. Right? We've got the younger adults, the middle-aged, and the older. So one of the things we can do is calculate the marginal distribution. So marginal distribution gets its name because we're looking at the numbers in the margin or on the outside. So this describes the distribution of one of the variables and kind of ignores the other one. So for example, we could look at the marginal distribution of phone type. So we would just look at the totals, the breakdown of who owns what type of phone. So for example, the iPhone, of all these people, ignoring their age, 467 out of 2,000-ish, that's about 23%. Okay, so we can see this breakdown of who owns what type of phone. One thing you might notice is that if we take all these percentages and add them together, we get just over 100% because of some rounding error, but we shouldn't worry too much about that. Cool, so we could also do the marginal distribution of age group. So we could do a separate marginal distribution of age, just looking at this margin. We can also look at a conditional distribution. So a conditional distribution describes the values that a variable of that variable among individuals who have a specific value of another variable. In other words, we would look at one variable given the condition that we have some other variable. It's hard to describe in words, I guess, but let's take a look at an example. Let's find the distribution of phone types for the age group 55 plus. So among this oldest group, what's the breakdown of types of phones they have? So this 55 plus, that's kind of our given condition. So given that the person is old, what's the distribution of phone type? Cool, so we could do that. So I've done that here. You can see the breakdown of the youngest group, so 18 to 34. We've got about 33% use iPhones and so on. Then we can take this middle column here. So the middle-aged people, we've got a breakdown of who owns what type of phone. And finally, for our 55 plus, the seniors here, we've got a breakdown of what type of phone they use. One really nice way to represent this type of information would be to use a stacked or a segmented bar chart. So these can be really useful. You can see there's a lot going on here. So first of all, I've got age on the x-axis, and I chose that for a reason, the same reason I chose to do a conditional distribution of age group instead of doing a conditional distribution of phone type. Because if we're thinking about which variable explains the other, and we'll talk more about explanatory versus response variables, it makes more sense to think about, does knowing a person's age help us figure out what type of phone they're going to use? I think so. But knowing what type of phone someone has doesn't really determine their age, right? That doesn't make sense going that way around. It doesn't make as much sense. So I chose age group as sort of the explanatory variable to put on the x-axis here. And then on the y-axis, I have relative frequency. In other words, I have percents on the y-axis, right? So all three of these add up to 100%. Okay, and then I have three segments to each bar. So you can see for the 55 plus, we've got about 15% use the iPhone, another 10% or so use the Android. It's not a beautiful chart, right? It's not perfect, but you can see the basic idea. And then we have the biggest part of the bar, about 74%, is that other category. One thing to note here is that on the AP test, you don't get to use colors, you get a pencil. So you can be a little more creative about, you can see how I put stripes on this. That's something you can do, and then you just want to make sure you include this key to show which part of the bar represents which value of the variable, in this case phone type. So you can do things like stripes or polka dots or like some shading, that kind of thing, to make the three segments distinct. So we can say there is an association between variables if knowing the value of one variable helps us determine the value of the other. If knowing the value of one variable does not help us predict the other, then there's no association, aka those variables are independent. So is there an association between age groups and cell phone type according to this data we were looking at? So if we look at this, we do see that each of these bars are pretty distinct, right? We can tell the difference between the 18 to 34 bar and the 55 plus bar. Those look very different. So just looking at this information, I'd say that yes, knowing an individual's age group can help us predict which phone type they are likely using. We'll talk more about how to really know for sure, looking into some probability, but for right now, I think this is a good enough explanation, is just looking at how much more likely you are to be using not an iPhone or Android if you're older. So again, association means that knowing the value of one variable helps us predict the other. So if we know we have an individual from this group and we know they're in the 55 plus category, that's going to help us predict what type of phone they're using. They're probably using something that's not an iPhone or Android.